Hydrolysis of salts. Salts are formed by the reaction between acids and bases. For example, NaCl is a salt formed by NaOH when it combined with the HCl. So NaCl is formed by the combination of an acid and a base. So there are two different type of acids and two different type of base. That is strong acid, strong base, weak acid, weak base. So we can expect 4 different type of salt. So here we are going to study on hydrolysis, that is by the addition of water, what happened to their pH, that is they are converting into acids or bases, or what is the pH of the resulting solution obtained by the hydrolysis of a salt. So 4 different type of salt we are considering. First one is salt of a strong acid with strong base. Salt of strong acid with a strong base. We'll take this example. So NaCl is the example. So during the addition of water, 2 things may happen. One is they can hydrolyze into acid or base, or they will simply hydrated and remain in the solution. They will not form acid or bases. In the case of strong acid and strong bases, we know that they contain cations with a low ionization enthalpy and anions with a very high electron affinity. So they will always remain in the solution and they will not undergo hydrolysis and result in the formation of acid and base. So all salts of strong acid and strong bases will simply undergo hydration. So their solutions will be neutral. They will not form acid or bases. So all salt of strong acid and base on hydrolysis, the resultant solution will be neutral. Their pH will be 7. Then second we'll consider salt of a strong acid with a weak base. We'll take an example. Strong acid of HCl combined with ammonium hydroxide will get a salt called the ammonium chloride. So this is apart from weak base and this is apart from a strong acid. On hydrolysis, we know that the part of from strong acid will not undergo hydrolysis, but the other one will undergo hydrolysis. So on addition of water, it will form ammonium hydroxide and H plus ion, that is from water. Then the Cl minus will remain the solution as hydrate. Then we know that ammonium hydroxide is a weak base. It will undergo very less dissociation, not completely dissociated. Then if there is 1 mole of this and 1 mole of this, only 50% a mole of OH minus ion will be there. So the concentration of OH minus, because it is a weak electrolyte, will be less than concentration of H plus ion. That is, we can consider like this. Ammonium hydroxide will remain like this because it will not undergo complete dissociation, but there is more H plus ions. So this type of solution will be acidic. So the salt of a strong acid with a weak base will be acidic. Then the third one, salt of a weak acid with a strong base. Consider weak acid, acetic acid and its salt with sodium hydroxide. Example is CH3COONA. sodium acetate. Here this is apart from a weak acid and this is apart from a strong base. On hydrolysis, we know that weak will undergo hydrolysis, so strong will undergo hydration. So what will form? Weak will form acid, and remaining what is there in water? OH minus, because in water H plus is taken by acetic acid and remaining OH minus. Then what is that? Na plus will remain there as hydrated. Here we know that acetic acid is a weak acid. It will undergo only partial dissociation. So H plus concentration will be less than OH minus. So here H plus concentration will be less and OH minus concentration will be greater. So the solution will be basic. So a salt of a weak acid and a strong base or hydrolysis, the resultant solution contain more OH minus ion. So that type of solution will be basic. Then the fourth one, that is salt of a weak acid with a weak base. Both are basic. Both are weak. So consider an example. Ammonium hydroxide and CH3CO. This is apart from weak and this is also apart from weak base. So ammonium acetate, that is the name of this salt. This on hydrolysis we know that both are weak, both will undergo hydrolysis. CH3COOH plus NH4OH. So we'll get a weak acid and weak base. Then what will be the resultant solution? Is it acidic or basic? So that we cannot say theoretically, we can find it by experimentally, because the dissociation of these varies. Maybe this is 60% and this one is 62%, or this is 70%, or this is 72%. We don't know the values of their dissociation, so we cannot predict theoretically whether that is acidic or basic. Or we can calculate their pH by using the equation. pH of this salt of weak acid and weak base, pH will be is equal to 7 plus half into their acidity constant pKa minus base acidity constant pKb. By using this equation, we can calculate the pH of the solution obtained by the hydrolysis of weak acid and weak base. So that's all about hydrolysis. Once again I will say there are 4 different types of salt. Salt of strong acid with a strong base, that will be neutral because they will only undergo hydration, they does not undergo hydrolysis. Then salt of strong acid with a weak base will be acidic, because weak base and weak base part will undergo hydrolysis and form a weak base, but it will not undergo complete dissociation. So concentration of H plus will be greater there. Then salt of a weak acid with a strong base will be basic. Then salt of a weak acid and weak base, we cannot predict theoretically whether it is acidic or basic. It can be obtained only by using the value of pKa and pKb, or knowing the dissociation rate of these two compounds. So we can find their pH by using this equation. pH is equal to 7 plus half into pKa minus pKb. Then one more thing, relation between Ka and Kb, acidity constant Ka and Kb. Relation between Ka and Kb. So we can take the same compound, for example NH4 plus. We know that it is a as it is an acid because it can donate one pair of electrons. NH4 plus on dissolving water, not electron, H plus. NH4 plus on dissolving in water, it will give one H plus to H2O and become NH3 and we'll get a hydronium ion. So when we write this is an acid, so we can write the acidity constant Ka. Ka will be equal to concentration of NH3 product into concentration of H3O plus divided by what is a constant we can avoid NH4 plus. Then same way another equation, ammonia when it is added to water. Ammonia can act as a base because it will accept an H plus. It will form NH4 plus and what is remaining OH minus. So as a base we can write the Kb. Kb is equal to NH4 plus into OH minus divided by what is that, NH3. We can avoid water because it is a constant. Its concentration is taken as a constant. So we will get the expression for Ka and Kb. Multiply Ka into Kb. Then right hand side, Ka is NH3, H3O plus NH4 plus. Then here NH4 plus OH minus NH3. The same thing here also, here you can cancel. So we'll get Ka into Kb is equal to concentration of H3O plus, that is H plus into OH minus. We know that this is Kw. So the relation between Ka into Kb is equal to Kw. This is a relation between Ka and Kb. So the relation is Ka into Kb will be equal to Kw. That is a relation between Ka and Kb for all. So that's all for today.